Good day, my name is Musa Zaruddin. We are going to have elementary differential equations. Just as its name is written, it's all about differential equation. First thing, let's try to define what a differential equation is. A differential equation is a function that connects an independent variable with a dependent variable. For example, b of x, y, y prime, y double prime, that is good, is equal to 0. Here, the dependent variable are y. That is good. These are the dependent variable. While the independent variable is x. So, for each of these, we have two types of differential equation. We have the ordinary differential equation and we have the partial differential equation. The ordinary differential equation is a differential equation that depends on one variable, while the partial differential equation depends on two or more variables. Like this, it depends on x and y, while here it depends on x only. So, for solution of a differential equation, it's all about removal of the constant. If you are given an equation y is equal to mx plus c, this is a differential equation. This is just an equation. To get the differential equation of this, you have to remove this constant m and c. So, number of constants will determine the number of times you differentiate a function. This contains two functions, so it is expected you differentiate it twice. So dy dx is equal to m is equal to m, because if you differentiate this x is 1, then you differentiate this, you differentiate c is 0. So then you differentiate again, d square y over dx square is equal to 0. So at this point, you can say f double prime of x is equal to 0. This is now a differential equation. Or some will write it in this way, y double prime is equal to 0. Whether it's written in this form or this form, all it means is the same. That's second derivative, d square y over dx square, or f double prime x, or y double prime. All it means is second derivative. So number of constant is the number of times we differentiate. Let's take an example. Let's say example 2. We have ay is equal to x plus 1. So ay is equal to x plus 1. So we have a constant a. You now take the first derivative. You take the first derivative. If you differentiate this, make a subject of the formula first. A is equal to x plus 1 over y. So now you differentiate this with respect to y. So if you differentiate this, you have a y prime is equal to, differentiating x, you have 1 and this is 0. So it is equal to a dy dx is equal to 1. So you divide both sides by a. So you have a dy dx divided by a 1 over a. This will go with this. We are left with dy dx is equal to 1 over a. Now this is not the solution we are looking for because our constant is still there. So you now go back by making a subject of the formula here. We substitute it into this. So dy dx is equal to 1 all over x plus 1 over y, which is equal to y over x plus 1. So the solution is dy dx is equal to y over x plus 1. So at this point, you have your first ordinary differential equation because the derivative is with respect is first derivative. So this first ordinary differential equation. Let's take another example. We have y is equal to a exponential x minus b exponential minus x. Given this, we have two unknown, a and b. So that means you have to differentiate it twice for you to get the differential equation, for you to have your solution. So the first derivative, dy dx, is equal to, if you differentiate this, you have a exponential x plus b exponential minus x. That's what you have. But if you take a look at this, the constants are still there. So you move on to the next derivative, second derivative, which is a. Differentiation of exponential x remains constant, it doesn't change. Then minus b exponential minus x. But our y is equal to a exponential x minus b exponential minus x. This is the same with our y. So we replace it by having d square y all over dx square is equal to, replacing it, we have is equal to y. So therefore our solution is now d square y over dx minus y is equal to 0. So this is our solution. take one more example. Y is equal to A cos theta plus B sin theta plus theta cos theta. Here the unknown are 2 also, because theta is a variable here, because we are differentiating y with respect to theta. So theta is not unknown. Our unknown are A and B. First thing, you take your first derivative, dy dx. Derivative of cos theta is minus sin theta. So you have minus A, your constant, minus A sin theta plus B. Derivative of sin theta is cos theta. Now up to the last term, theta cos theta. These are 2 terms. We have theta and we have cos theta. So product rule. That means first we differentiate this, we keep this. Then plus we differentiate this, we keep this. So for the first one, we keep this and differentiate this. We have minus theta sin theta, then plus. For the second one, we differentiate theta and keep cos theta. Then the second derivative, d square y over dx square. For the second derivative, we differentiate again. We are going to have minus a. Differential of sin theta is cos theta. Then this we have minus b sin theta. This you use product rule again. You have the minus theta cos theta plus sin theta. Then minus sin theta. So d square y all over dx square is equal to so you have minus a cos theta minus b sin theta minus theta cos theta minus sin theta minus sin theta. So from here we can factor out our minus sign. We have minus a cos theta plus b sin theta plus theta cos theta minus 2 sin theta. If you compare this to our question given, this is the same thing as y. So it is equal to minus y minus 2 sin theta. So finally, d square y all over dx square is equal to minus y minus 2 sin theta which implies our solution d square y over dx square plus y plus 2 sin theta is equal to 0 is equal to minus 2 sin theta. So this is our solution. I think that's it for solution of differential equation. Now, their method of solving this is just the general method of solving the differential equation, ordinary differential equation. There are also methods of solving differential equation. We have method of variable separable. So the first method we are going to work on is method of variable separable. Just as the name implies, this is a method whereby you separate the variable of x from that of y before you then solve. This deals with more of integration. So you have to have at least a prior knowledge of how to integrate. If you are given, let's say, for example, dy dx is equal to f of x. From here, you can see dy by cross multiplying is f of x dx. We separated the variable of y from that of x. Same thing if you go with that of, let's say, the y dx is equal to f of y. It can also be written as dy all over f of y is equal to dx. Also, if you have dy all over dx is equal to f of x all over g of y. If you are doing variable separable, you will have g of y dy is equal to f of x dx. So variable separable is all just talking about how to separate the variable of the numerator, the independent and the dependent variable. You separate them before you start solving. You separate them before you start solving. So if we take an example, let's say example 1, you are given dy dx is equal to is equal to 2. Clearly from here, 2 is a constant. So 2 can be, you can differentiate it, you can integrate it, you can take it as a y variable or as an x variable. First, let's start with as an x variable. So you have dy is equal to 2 dx. So to eliminate this differential sign, you integrate. So integrating the y is equal to 2 integral of the x. Since 2 is a constant, there's nothing to integrate. So integration of dy, you have y. The integration of dx, you have x plus constant of integration. So this using variable separable. Then if you take 2 to be constant of y, if you take 2 to be constant of y, what you have is dy over 2 is equal to the x. So if you integrate 1 over 2 dy is equal to integral of dx. You have y over 2 is equal to x plus c, constant of integration. So if you cross multiply, y is equal to 2x plus c. So we arrive at the same answer as this. So because 2 is a constant, you can take it either way. Be it constant of x or constant of y. So we have dy dx is equal to 2x minus 3. Here automatically you take this as constant of x. Then if you use variable separable, you have dy to be equal to 2x minus 3 dx. So you integrate both sides. You have integral of dy is equal to integral of 2x minus 3 dx. So you will have integral of dy is y, integral of 2x is 2x squared over 2 minus 3x plus constant of integration c. So your solution is y is equal to x squared minus 3x plus c. So this is your solution. You may be given this type of question and asked to find the line passing through, let's say, at 4,5. That's this equation at 4,5. What it means is x is equal to 4 while y is equal to 5. So after arriving there, you will now substitute this 4 and 5 into the equation. And so our equation is y is equal to x squared minus 3x plus c. So x squared minus 3x plus c. Your y is 5. Your x is 4 minus 3 times 4 plus c. Then you have 5 is equal to 4 squared is 16 minus 12 plus c. 5 is equal to 16 minus 12, 4 plus c. Make c the subject of the formula. C is equal to 5 minus 4, which is 1. So therefore your equation y is equal to x squared minus 3x plus 1. So this is the final solution. Let's take a little bit complicated one and see. These are all more of the basics. So if you are given dy dx is equal to, let's use trigonometry function, sec square y. This is a trigonometry function which sec square y is 1 over cos square y. So since this is y, it moves to the left hand side. So you have dy over sec square y is equal to dx. So if you integrate, so 1 over sec square y, this can also be written in another form, whereby our dx is equal to cos square y from trigonometry, because we know that cos y is equal to 1 over sec y. So once there is square, it goes like that. Then you integrate both sides. Integral of dx is equal to integral of cos square y dy. So for the left hand side, there shouldn't be a problem. But for the right hand side, for the left hand side, there shouldn't be a problem, which is integral of dx. But for the right hand side, we have to do some manipulation first. You have integral of dx is equal to integral of 1 over 2. From trigonometry, we all know that 1 cos square y can be written as 1 over 2 cos 2y plus 1 dy. So by writing this, our integral will be a lot more easier. So integral of dx is x is equal to, we have 1 over 2 integral of cos 2y is sine. So we have sine 2y all over 2. Then integral of 1 is y plus c, constant of integration. So if you open up this bracket, you will have, starting from this side, you have 1 over 4 sine 2y plus y over 2 is equal to x plus c. Constant of integration never carries a negative sign. It is always positive. So be it on the left hand side or on the right hand side, it is always positive. Then by simplifying, you have y, then you multiply through by 2. You have y to be equal to x minus 1 over 2 sine 2y plus c. So this is our solution. So finally, this is our solution. Then we move to the next method. We have method of first order exact differential equation. So for this method of exact differential equation, you have to have a prior knowledge of integration by part, and also method of variable separable. Because there are some differential equations that even after using this method, you will not get the solution. So at a point whereby you won't be able to find a solution, you now have to force it to be exact. That's by using integration by part and variable separable. So first, we consider a differential equation. The standard of a differential equation dy dx is equal to f of x. That's the first thing you consider. Then you will now find, so if we consider double variable partial differential equation, so f of x comma y is equal to minus m x comma y all over n x comma y. We'll use this to substitute for f of x comma y. So from here, if you cross multiply this, you are going to arrive at n x comma y, f of x comma y is equal to minus m x comma y. And this is written, this f of x comma y is written as nx comma y dy all over dx is equal to mx comma y mx comma y. So if you cross multiply this, you will have n dy is equal to m dx. So from here, we move on to integration. Because our aim is to find, eliminate any constant. And both m and n are our constant here. So we take this as our, let's say, equation 1. So from here, you can differentiate this by saying m dx is equal to m dy. Differentiating m with respect to y, partial derivative of m. So partial derivative of m all over partial derivative of y is equal to partial derivative of n all over partial derivative of x. Because m consists of both x and y, same as n consists of both x and y. So you cannot differentiate completely. You have to differentiate it partially with respect to y, partially with respect to x. After differentiating, if partial derivative of m over partial derivative of y is equal to partial derivative of n partial derivative of x, if this is equal, then the solution exact, whereby if partial derivative of m or partial derivative of y is not equal to partial derivative of n all over partial derivative of x, then the solution is not exact. When the solution is not exact, either of the following: either you force it to be exact, then solve, or you change method. Because for solution of differential equation, we have probably 4 methods: variable, separable, exact, then homogeneous, then series solution. So I think this is where we are going to stop. If you have maybe in our next class, we will solve example under exact solution. If you have any question, you can drop it in the comment. Thank you.